Hi. In this video, what we're going to do is work with stacks, and we want to use a stack in this case to convert a decimal number into binary numbers. Okay. So let's do an example here. Let's say we have 233 as a decimal number. Well, how was that actually broken down? Well, what this would be 2, my cursor in the right place there, 2 times 10 to the squared, okay, plus, because that's the position that it's in, 3 times 10 to the first power, plus 3 times 10 to the 0 power. Okay, so 2 times 10 squared is 100, times 2 is 200. Okay, 3 times 10 to the first power, 10 to the first power is 10, times 3 is 30. And 3 times 10 to the 0 power, 10 to the 0 power is 1, so that would be 3, so it would be 233. Okay. Binary works the same way, except it's by the powers of 2. So we would have 1 times 2 to the 7th power. Then we would go to the next one, which would be plus, the next is the 1 times 2 to the 6th power, plus 1 times 2 to the 5th power, plus, this time we have a 0, times 2 to the 4th power, plus 1 times 2 to the 3rd power, plus 0 times 2 to the 2nd power, plus 0 times 2 to the 1st power, plus 1 times 2 to the 0 power. So then what you do is you take all of these, and what you have here, this is 1, so that's 1. Do the 0, this would be 2, but it's times 0 is 0. This would be 4 times 0 would be 0. This would be 8 times 1, it would be 8. 16 times 0 would be 0. 32 times 1 would be 32. 64 times 1 would be 64. And 128 times 1 would be 128. So you'd add up the 128, the 64, the 32, the 8, the 4, and the 1. Okay? So that's how that works on there. So what we're going to do now is we're going to go ahead and work with the stack that we've already created and come up with a program that will allow us to do this conversion from a decimal number to a binary number. So to do this, what we're going to need to do is import our stack. So from stack, import stack, I'm going to call our function divide by 2. We're going to pass in a decimal number. So we're going to have our REM stack for remainder stack. And what we want to do, when we do the divide thing there, actually the numbers that we get are going to be in reverse order when we do the divide on there. So that's why we put them in the stack, so that when we pop them off the stack, they'll be in the right order when we print them out. Okay. So rem stack equals DEC number mod 2 rem stack dot push our REM. I left a line out here, I think. REM. Yep, I left a couple lines out here. So let's do this again up here. This is going to be the REM stack equals stack to create our stack. Then we're going to do a while loop. While DEC number is greater than 0, we can process. And in our process, we want to calculate out what our remainder is from doing this modular division here. And then another line in here, we want to, nope, that's right, we want to push that onto the stack, and then we want to come up with our new decimal, getting rid of the value of what would be divided by 2. So we go to the decimal equals decimal number, integer division 2. So if we were doing 5, let's say as our number, decimal number, then 5 is greater than 0. We take 5 mod 2 is going to be a 1. 1 gets pushed onto the stack. Then we take our 5 divided by 2, which is going to be 2. We do away with the remainder, and that's this here. It's greater than 2. So then we do our rem stack is going to be equal to our 2 mod 2, which is 0. 0 gets put into that, so it gets pushed onto the stack. And then 2, integer division 2, is 1. So that's our decimal number. 1 is greater than 0. Our remainder, 1 mod 2, is 0 with a remainder of 1. So 1 gets pushed onto the stack. We then take our our 1 mod 2, which is going to be 0 as the result. That puts in the decimal number, which then is not greater than 0, so it drops out. Okay. So then on here, we're going to push out the 1, then pop out the 1, then the 0, and then the 1. Okay. So once we get that there, we're done with the while loop. We're going to set up a variable called bin for binary string, equal to quote quote, while not rem stack dot is empty. So while we have something in the stack, our binary string plus equals str of our rem stack dot pop. Okay. And then we're going to return our binary string. So let's create a main that we can test this with. We're going to get our number. Have them enter a decimal number. While number is greater than 0. We'll go ahead and process this. We're going to print number as binary is divide by 2, passing in number. Print out a blank line, and then we're going to ask them to enter a number again. So I'm going to go ahead and copy and paste this. I messed up on my copy there. Let's try that again. And I want to add on to the back on the end of this, put in 0 to quit. Okay. So now all we need to do is call main. Let me get this saved. I'm going to call this DEC to bin. .py. I already have that in there, but I'm going to save over the top of it. Okay, so let's run this and see what happens here. Let's do an easy one. We'll do 5. Oops. Oh, okay. I messed up here. This should be rem here instead of rem stack. Okay. So let's try this again. Put 5 in again. And there we get our 101. That was a test. So let's do the one that we created here, which was 111-01001. Oh, sorry. I wanted the 233. And there we get the 111010001. I put in a binary number, and we got a really big binary number back. That was actually a decimal that looks like a binary number. I'll put 0 in to quit. Okay. So that's one aspect of this. Now, another aspect is, what if we actually want to do a program that will work for any base? So we're going to change this program around a little bit. I'm just going to modify this program here. I'm going to change the name to base converter. And to do this, besides the number we're passing in, we also need to pass in the base. Now, for this to work, if you remember, hopefully you've had a little bit of what like base 16 is. Base 16 goes 0 through 9, but then there are no digits, whole digits after that. So what they use is A, B, C, D, E, F for 10, 11, 12, 13, 14, 15. So we're going to create a string called digits. It's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay. We're going to create our stack. While our number that we pass in is greater than 0, we're going to divide our decimal number by the base. We're going to push the remainder onto the stack, and then we're going to divide our decimal number by the base. Up here we're getting the remainder. Down here we're getting the quotient on that. I'm going to change binary string to new string, while not stack rem stack is empty, meaning that while it's not empty, we're going to process. I'm going to change this to new string here again, str on the pop, and then return our new string. Now the main, then we're going to get that number. While the number is greater than 0, we need to get the base. Okay, so we're going to print, and I'm going to modify this, print number as, in the quote there, and then this will be base here, comma, and then put a quote on the is. And then we need to change this to base converter and add base and print on passing that into our function. Okay, so I'm going to resave. I'm going to save this one as another name. I'm going to save it as base converter. .py, and then let's run this. Squeeze this down here so you can see this here. Okay, so again, let's put in our decimal number as 5, and the base we're going to do is 2, and it comes back as 101. This time, let's put in 10 as our decimal number, and we're going to put in 16 as our base, and we get should have got A. So I think I know what I did wrong. Yep, I forgot to change this in here. Instead of doing this up here, the new string plus equals is not this. The new string plus equal is going to be digits sub rem stack.pop. Okay, and I forgot that we had to make that change in there because we want to pull it out of here. So when it comes back as 10 as being the number, we want it to print the A. So let's run this again, and I'll skip over the beginning one. We'll just go ahead and do the 10 as a base 16, and we get the A. Okay, so I hope this helped you out a little bit on understanding how stacks work. And I'm going to do another video on stacks doing another program on this. So hopefully this gives you some insight into that.